Hi guys, I will explain Laminate Theory Part 6 from idea development for zero plies tier to summary. Here I have a quiz for you. What is the correct description about the laminate code symmetry of plus minus 30? It has the in-plane cross-coupling. It has the out-of-plane cross-coupling. It has both of in and out-of-plane cross-coupling. It has no cross-couplings and this type of laminate. We have been familiar with the expression of the stiffness matrix in the previous videos. We've known that there are three kinds of submatrices: normal stiffness, bending stiffness, and finally normal and bending coupling stiffness matrices. The stiffness elements related to plies tier are A16, A26, B16, and finally B26. Therefore, we have to set the stacking order of plies of the tire so that all those four elements are equal to 0. This shows all the causes for plies tier. Plies tier can be produced due to tire belt and the tire pattern block, and the plies tier due to tire belt can be produced by either in-plane coupling or out-of-plane coupling, or both of them. I have explained the in-plane coupling in the video number E31, and we are here in the middle of this topic. Tire pattern block will be next topic. Here we have some definitions to explain the deformation of laminate. A thin solid blue line is for front ply. Thin broken red line is for rear ply. Bold broken arrows, both of red and blue, mean deformation quantity and direction of front ply. A red bold arrow means strong direction. Blue bold arrow means weak direction. Bold solid arrows, both of red and blue, mean deformation quantity and direction of rear ply. Other definitions are the same as before. I explained this behavior of deformation in the previous video, E32. This laminate code is minus plus 30 in the direction from D to positive Z axis. Top and the bottom of this laminate will turn in opposite way under the tension force, so that point A and C are forward on the screen, and the point B and D are backwards on the screen because of stiffness difference between two diagonals in the picture. So curvature are opposite each other. We can make all the out of deformation displacements of laminate equal to 0 if we find another corresponding laminate exactly opposite to those displacements. Here we have an idea. The front ply of this laminate is exactly the same as the rear ply of previous laminate, and the rear ply of this laminate is exactly the same as the front ply of previous laminate. In other words, this laminate code is plus minus 30. On the other hand, previous laminate code is minus plus 30. In this case, all the out-of-plane displacements of this and the previous laminates have the same size but the opposite direction to each other. Consequently, we can make all the out-of-plane displacements equal to 0 if we put them together in the appropriate order. We can cancel out all the out-of-plane displacements due to tension force for each laminate minus plus 30 and plus minus 30 by putting them together as one body. As you can see here, displacement A cancels out that of E, and B does F, and C does G, and D does H. As a result, we can be sure that laminate code minus plus 30 symmetry does not produce out of plane displacements and just stay flat shape under the tension force. This picture describes the stacking order of plies for the laminate with all the stiffness matrix element of B equal to 0. It means there are no out-of-plane displacements. In this laminate, ply 1 is exactly same as ply 4, and ply 2 is exactly same as ply 3. The laminate code is minus plus 30 symmetry. When minus plus 30 symmetry laminate is loaded by tension force, all the out-of-plane displacements of ply 1 and ply 2 have exactly the same quantity, but the opposite direction to those of ply 3 and ply 4. Therefore, their effects are cancelled out each other. The principle for making all the out-of-plane displacements equal to zeros can be explained by curvatures. As you can see here, the plus and minus curvatures of first set of plies cancel out the minus and plus curvatures of second set of plies. Minus and plus curvatures of first laminates cancels out plus and minus curvature of second laminate respectively. As a matter of fact, every curvature at the arbitrary section of the first laminate is exactly opposite to the one at the corresponding section of the other symmetric laminate. They have the same quantity, but the opposite direction of curvatures. We can get the same result for the other sequence order, so that we place ply 3 first, then ply 4, ply 1, and finally ply 2. Laminate code for this case is plus minus 30 symmetry. The same way as before, all the curvatures of first set cancel out the other corresponding curvatures of second set. As a result, this laminate can stay with a flat plane shape under the tension force. Here we have the stiffness matrix for laminate code plus minus 30 symmetry. All the elements of B matrix are equal to zeros, and both A16, A26 are all equal to zeros. That means there are no in-plane and out-of-plane coupling in this laminate. This type of laminate is called symmetric balanced laminate. All the stacking order here are the balanced symmetric laminate, which I explained in the previous video number E36. All the laminates here have all zeros per B matrix elements and also zeros for A16 and A26. Symmetric balanced laminate is a symmetric laminate composed of balanced pairs like plus theta 1 minus theta 1 plus theta 2 minus theta 2 symmetry. Therefore, corresponding laminate codes always include plus minus for being balanced and the lower script S for symmetry. The answer to the quiz is number 4. It has no cross couplings in this type of laminate. Here we have a summary. The appropriate stacking order of plies of the tire can cancel out out-of-plane displacements resulting in ply tear. The principle for making all the out-of-plane displacements related to ply tear equal to zeros can be explained by curvatures. Symmetric balanced laminate can get rid of in-plane and out-of-plane couplings and end with no ply tear. If you watch the previous videos, you can easily understand upcoming videos. In the previous video, E36, I explained how to interpret the stiffness matrix elements and also the compliance matrix elements and the laminate codes. Recently, I explained the various types of stiffness matrix and their elements. Next video will be plies tier part 12. I will explain the relationship between plies tier, lateral force, and the self-aligning moment. Please hit the like and catch the brand new videos by pre-subscription. So, what are you waiting for? Goodbye guys!